Yeah, you should be having with you on the screen the question paper. In case you don't have a copy with you right there at hand, it's also okay to have with you a calculator, so that during the process of the calculation, if there is something that we need to check the value, you also participate in it. You know, mathematics is not a passive subject. You have to participate in the process right from the start. So make sure you do have a calculator with you, and if you do have somewhere to write a few things, it's also important, because as time is going on, there are some things that you might consider noting down, and you check through again, and you use that concept to help you with the next question, which might appear. So question 2 is right here. In case you're not able to see question 2, just write and let me know. Just message in the chat box and I check it out. Otherwise, question 2 reads, the graph of f of x equals to negative square root of 27x for x greater or equals to 0 is sketched below. The point P with 3 and negative 9 for x and y respectively lies on the what? On the graph of the function. So, well, this is the graph, and the function given is the function f of x defined by negative square root of 23, negative square root of 23 what? 23, rather 27x. Yes, it is all, yeah. So yes, this is the function that we are dealing with. Now the question we want to start with, oh yeah, I guess you can now see, possibly there was a delay. So yes, the question we are handling is question 2. The graph of the function is already sketched for you here, is already drawn for you. The function is a function f of x equals to negative of square root of 27x, and it's for values of x starting from more than 0, okay? That is 0 onwards, starting from 0 onwards. And now the first question we have to deal with is the question requiring us to use the graph to determine the values of x for which the function f of x is greater or equals to negative 9. So you see here, basically, we are not going to do any calculation. What we are supposed to do is we just look at the graph. Then when we look at the graph, we check through to determine for what values of x will the function, which in this case is the value of y, okay? So for example, this is where the graph starts, because the graph starts at x greater or equals to what? To 0. It's very important that you take care of this one here. You see this is very important. The graph starts from the value of x equals to 0 onwards, you know, increasing. So if we are to determine the value of the function or the value of x for which the function will be less, rather the function will be greater or equals to negative 9, then we check from here through. Now notice that the value of the function at negative 9 has been given as here. So our task now is to find this range or the values of x. How do we determine that? Let's check. Supposing, okay, because at this point here, you see that x equals to 3 and the value of the function, or rather y equals to negative 9. So at this point, when we increase the value of x, as an example, when we increase the value of x, say from 3 to 4, okay, what we notice is the value of the function, the value of y is going to be somewhere here, okay? And what is that value of y going to be? Well, that value of y is going to be something which is less than -9. Notice it will be going down this way, okay? Because as you go up, it will be increasing. So as you go down, it will be decreasing. Now, if we increase again from 4 to 5, if we increase the value of x from 4 to 5, it will be roughly somewhere here. Now, when we drop a line to come and meet the function, we notice that the value of the function is going to be less than, okay? It's going to be less than -9. The question is requiring us to find the values of x for which the function is greater or equals to what? -9. Now, notice that x is greater or equals to -9. Rather, the function is greater or equals to -9. And those values will be -9, -8, -7, -6 in that order. Those are the values greater than -9, okay? So those are the values that we will be having up this way. And so if from 3, for example, we move on to the left, that is, we decrease the value of x, say by 1, and we move to 2. So you notice that when the value of x equals to 2, and we drop a line here, this is at this point here, this is the point, for example, where we will be. And the value of the function is going to be what? It's going to be like roughly, say, negative, maybe 7, you know, just roughly somewhere there. Then when we decrease to 1, we drop a line here. The value of the function is going to be like, you know, something like negative, maybe 5. And those values are greater than -9. So in general, the values of x that will make the function greater or equals to -9 will be the value of x starting from 3 getting to 0. Now, we are not going to include values less than 0 because the definition here is that x for this function starts from a value which is either equals to 0 or what? Or greater than 0. So how do we conclude? Well, we then conclude that the values of x starts from what? Starts from 0 up to 3, okay? So let's create a page where we are going to be answering, and we make it big enough so that you guys can see nicely. And so for 2.1, so for 2.1, x. Okay, so for 2.1, we have seen that the value of x will start from 0 all the way up to 3, okay? That means 0 is included. So x can either be 0 or greater than 0, okay? We can write it as x can either be 0 or greater than 0. That is what? That is greater or equals to what? Or equals to 0. Up to when? Up to the value of x equals to 3 or less than 3, okay? Equals to 3 or less than 3, like that. So in general term, we would like to write it as, we can therefore write it as x lying between 3, that is 0 and 3. So we say x, the upper limit is going to be 3, and the lower limit right here, the lower limit is going to be what? The lower limit is going to be 0. And that gives us the what? The solution. So instead of having this, you know, our final answer is this, okay? So let me just remove that one. Place the what? Final answer right there. So yes, this is our value of 2.1. The next question is 2.2. Let's check through right away. So 2.2, we are supposed to write down the equation of the inverse function f in the form y equals to that value. All right, so let's see how we are going to get started for this question. Now we have been given that f of x is this function defined by negative square root of what? 27x. Let's copy this before we do what? Before we begin to discuss the inverse function. So we say this is 2.1. Now 2.1, this is what we have. Unfortunately, it's not accepting. So let me just type the whole thing. So the function f, of x equals to the minus square root of what? The minus square root of 27x. Now, the steps in finding the inverse function f. The first one is to let some other value. In this case, we let what? We let, say, y equals to this value, which is minus square root of 27x. So that is the first step, 27x. Then in the second step, we interchange x and y, meaning where there is x, we write y, where there is y, we write x, okay? So very much like we have be having, okay? So from this, we then interchange. Oh, all right. So we say x is now equals to the minus square root of 27y. You see? So basically what we did was to interchange x and y, meaning where there is y, we write x, and where there is x, we write y. Well, that's the next step. Then the step which comes after that is to determine, is to solve for y. How do you solve for y in this case? Well, to solve for y in this case, let's first write the whole thing. So to solve for y in this case, from x equals to the negative or minus square root of 27y, to solve for y, not x. X is already given by this expression. So to solve for y in this case, since y is inside a square root sign, the first thing for us is to square everything, meaning we have to square the terms on the right-hand side, then later we'll also square the terms on the what? On the left-hand side. What I'm actually trying to say is everything on the left-hand side, which I have highlighted, okay? We can first put it in the bracket like this, you know? All right, then we square it, okay? Then we square the whole quantity. Okay, so let's square that way. And since we are squaring the quantities on the right-hand side, we must also do what? We must also square the quantity on the left-hand side. And when we square the quantity on the left-hand side, okay, very much like this, we have to square this quantity on the left-hand side that way. Then in the next step, okay, in the next step, we will then be having x squared on the left-hand side, okay? On the left-hand side, we will then be having x squared, and on the right-hand side, that is x squared on the left-hand side, and on the right-hand side, we will now be having, well, the square of this is the same as this quantity times itself. What this then means is the minus will multiply itself with a minus, and it will becomes a plus, okay? Then this square root sign will also multiply itself. In other words, it will disappear. We will be left with the 27y. That is going to be our value of what? That's going to be the expression we have on the right-hand side. Then now one more step, which is very much like the last step before we conclude, is to divide the right-hand side by 27 and also the left-hand side by 27. Okay, so from this expression or from the equation x squared, from x squared equals to 27y, when we divide what is on the right-hand side, yeah, there is a question here, just before we conclude. There is a question that now, considering what we are doing, which is finding the inverse function f of x, would it be wrong that we divide, with the negative? For example, we divide this side, or we multiply this side by negative and this side by negative, or we divide this side here by negative, or also we divide this side by negative. There is no problem with that. You will not be wrong, okay? Because when you divide right-hand side, okay, the quantities on the right-hand side with negative, this negative will disappear and will come onto this side. So we will now be having what? Negative on the left-hand side, and all the quantities on the right-hand side will be positive. The step, which is very important, is the step of squaring. Because if you miss that step of squaring, you will find the negative still appearing somewhere. Now, if you had used the method of dividing the right, okay, this one's by negative and this other side by negative, you will have transferred the negative onto the left-hand side. And you see, you would now be having what? Negative x. That you have to square, okay? So if you had brought it that way, squaring negative x would still give you positive x squared. Okay, that is how it would be. Transferring negative from the right-hand side to the left-hand side, there is no problem with that. You will not be wrong, okay? So that is for your question. In case you do have other questions, you can be asking, you just type it down or you can say it out. Now, after reaching here, the step that we have to take is the step of transferring 27 where? Onto the left-hand side. How do we do that? By dividing the right-hand side, the quantities on the right-hand side by 27. And we also do the same for what? For the quantities on the left-hand side. And that will give us x squared divided by 27. That way, we now find the value of what? We find the value of y. And so we can therefore conclude that what? We can therefore conclude that y, which is now going to be the quantity on one side, we would like to place it right away on the left-hand side, is going to be equals to what? It's going to be equals to x squared divided by 27. So there we go, x squared divided by 27. So yes, this is going to be the inverse function of the function f of x equals to what? Equals to the minus of square root of 27x. So yes, this is how you do what? This is how you determine the inverse function. And that is the solution to question 2.1. Okay, so in case there is something that you would like clarification on, just feel free to text. Otherwise, we are going to be moving on to the next question. And what's the next question? Well, the next question in this case is 2.3. Now, this question is requiring us to sketch, okay, to sketch the graph of the inverse function of x on the diagram sheet. All right, so the diagram sheet is right down here. Yes, this is for question 2.3. We are supposed to make a sketch of the inverse function. Well, we calculated the inverse function as this value. Now, to make a sketch of this, now notice that the inverse function is always a reflection along the line y equals to x, okay? The inverse function of any function is always a reflection in the line y equals to x. That is important for you to know because it will help you have a general picture of how your graph will look like. But as always, you know, you want to determine some key points, like for example, what is the x-intercept, what's the y-intercept, you know, stuffs like that. Now the x and y-intercept, just really quick, this is 2.3. When you look at this graph that we are dealing with, it starts from 0, 0, 0, that's the origin, and it extends like this. The line y equals to x is a line which cuts like this. And the inverse function is the reflection along that line. You know, it's like when you have a mirror placed before you, okay? So the mirror is going to be the reflector. So your image will be reflected onto the mirror. So in the same way, we have to reflect this function along this line. So how do you reflect that? Well, let's make it a little bit easy. We just find the x-intercept and the y-intercept. And as we find the x-intercept and the y-intercept, it will become clear to us what exactly the shape of the graph is going to be like. All right, so there we go. From here, let's say x-intercept. So x-intercept occurs when what? When y equals to what? To 0. So what is the value of x going to be when y equals to 0? Now notice that when we put 0 for y here, then we will have to cross multiply, okay? And so we will multiply 27 by 0 and we get 0. Then x squared times 1, which would be the what? The denominator. And we get what? We get x squared on one side and 0 on the other side. So one thing we notice from here is that I wish this thing could allow me copy, and it's not allowing. All right, so let me just put it, just write the whole thing. So we have from y equals to the square root of, okay, from y equals to the square root of x squared divided by 27. So what I said is, if we put 0 here, the next step is for us to do what? To cross multiply. Now, cross multiplying here means we have to multiply 1 by x squared. And when we multiply 1 by x squared, what we get is what? Is x squared. Okay, that's what we get. Then on the other side, we then have to multiply 0 with 27. What do we get for that? We get 0. And so we then want to find the what? The square root of 0. I mean, that is going to be the value of x. We determine the value of x by finding the what? The square root. And what's the square root of 0? It's also 0. And so the thing we are dealing with now, the coordinate is going to be, or the intercept will occur at the point x equals to 0 and what? And y equals to 0. So yes, that is important because it makes you now see some other points that what? That the function is going to pass through, or our graph is going to pass through. So there we go, 0, 0 is one of the points. Now the next thing here is to determine the y-intercept. Okay, so let's say y-intercept. So how do we determine the y-intercept? Well, the y-intercept is the value of, or the coordinate, or the point when x equals to what? When x equals to 0. That is, y-intercept occurs when x equals to 0. So again, right inside here, when we substitute, okay, in our equation, which is y equals to x squared divided by 27, what do we notice there? Well, it's still the same thing, okay? it's not undefined, it is defined. You know what I'm saying is from y equals to x squared divided by 27. That is x squared divided by 27. What we have here is that when we put 0 for x, okay? When we put 0 for x, what are we going to get? Yes, we are going to get the value of y. And what will it be in this case? The value of y is going to be, well, what is it when you divide, you know, when you divide 0 by some other number, you get 0, okay? You get 0. But when you divide, for example, 27 by 0, that is what you get, rather, that is when you get undefined, okay? So 0 divided by some other quantity is 0. But any quantity divided by 0 is what? Undefined. Please get that. It's not that value which is called undefined that you would get in this case. So what do we have right now? Well, what we have right now is the y-intercept, which is occurring at 0, what? 0, 0. What else do we need? Well, let's consider having one more point, just to help us have, you know, a fair picture of how our graph is going to look like. So just taking any point, we say one more point. One more point. And we just choose. So we'll be like, let x equals to what? Let's x equals to, say, be like 4. Let's x equals to 4. So we say at x equals to 4, just choosing any point. So what's the value of y going to be? Well, the value of y is going to be x squared, which is 4 squared, okay? It's going to be x squared, which is 4 squared, divided by 27. What we are doing here is we are choosing one more point so that we have a better idea of, you know, what other points will the function pass through, okay? So this is what we are dealing with. So now we are substituting 4 for what? We are substituting 4 for x, like that. And when we do that, what we get is 16 divided by 27. And what is 16 divided by 27? Well, that now requires me to get a calculator. So in case you do have one with you right over there, it's fine. Just go ahead and get us the solution. So we are getting 16 divided by 27. That gives 0.59, which is roughly 0.6 or 0.6, like that. So yes, now our graph right here, we have seen that there is what? There is 0, 0. So as I told you, the earlier picture is very important, that the inverse function f is a reflection along the line what? Along the line y equals to x. This is going to help us now that we already got 2 points. The first point is 0, 0, meaning our function or our graph will start from here, 0, 0. Then the next point, which we just calculated, is what? The next point is 0 for x. No, not 0 for x, 4 for x, and 0.64 for y. Let me just put it right down here. The coordinate system. So it's going to be 4 for x and 0.6 for y, or for the function. So there we go. Let's look for 4 for x and 0.6, right? Yeah, so 4 for x and 24 for x and 0.6 for y. Yeah, 4 for x. So let's see where it is going to be. Where is 4 for x? 4 for x is going to be somewhere here. And 0.6 is just slightly up here. Oh, now that is very small for us to see, because 0.6 for y is just over here, okay, and 4. So it's like, if we are to, because 4 is here and 0.6 is somewhere. So is this what we are going to have? No, this is not what we are going to have. We could have got some other value, okay, some other value, but in a rather general case, we would rather have maybe, okay, let's just take one more value, because this one has become too small, a value that would make y fairly big enough for us to see, okay, fairly big enough for us to see. Let's choose, for example, another value of x, let's say -5 this time, so that we can have a fairly big value. You know, when it comes to graphing, you can always choose more point in case the points you have are not as good as what you're expecting. So we are going to have one more point. This time, okay? One more point. This time, let's choose, say, -5. No, let's choose like -10, yes. That is x equals to -10. So what's the value of y going to be? Well, the value of y is going to be x squared, okay, which is -10 squared. That is from x squared divided by 27. Like that. So the value of x in this case is -10. So let's substitute right inside there. -10 for x. So what do you have for that? That is going to be 100 divided by 27. So let's see what we get for that. 100 by 27 on a calculator. 100 divided by 27, that is 3.7. 3.7, okay? Or 3.7, just that. Now, we have what? We have this point that we are going to, which is going to make things a little bit easier for us. So we have -10 here, and the other thing we have is what? The other thing we have is 3.7, like that. So we go ahead to plot this, and we see where it will be. So plotting this will give us -10 is going to be this side. You see? This side here. And 3.something is going to be somewhere up here. Somewhere up. So you now notice that what we get here is going to be a graph which extends like this, like this, like this, like this, like this, making this type of curve, just like this one here, you know? So it starts from here, because this is the intercept, which was there for all the 2 points, the y-intercept and the x-intercept. So the graph will extend, 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 extend all the way that way. So that is how you would sketch the what? That's how you would sketch the graph. Next question. I mean, the program I'm using is Microsoft Office, which is not having the graphics for drawing. So I'm just illustrating for you so that you see how you can do what? How you can go ahead and sketch it. Those points, the intercepts, and 2 points has been adequate for us to do what? To sketch the graph. Next question, which I guess is the second last question, is, yeah, last question. Yeah, so the last question here is, we are supposed to describe the transformation of f to g if g equals 27, rather the square root of 27x. What is this supposed to mean? How do we describe the transformation? Okay, how do we handle this case of describing the transformation? So to describe the transformation, we have to look at this function, the new function which we have been given, which is the function g of x. We We also have to look at the what? We also have to look at the original function, which is the function f of x. Okay. So just a minute. Let me first connect. My battery is getting really low. All right, so there we go. Now, the last question is, (2.4). The function we already had is the function f of x, okay? Is the function f of x equals to what? Equals to the minus of square root, okay? The minus of square root of 27 what? 27x. Like that. Now, we have been given a new function. And what is that new function? The new function is the function g. G of what? G of x, okay? It's also a function of x. And this new function is given as the square root of 27, excuse me, 27x. That's what we have. What's the question? The question is that we describe the transformation, okay? We are supposed to describe the transformation. The transformation of f to g, okay? We are supposed to describe the transformation of f to g. In other words, the question is asking, what happened to f that got us g? You see, that is actually what the question is asking for. So how are you going to describe that in a mathematical way? What are you going to say? What will you say will have happened to f so that we get g? Now, the thing you notice here is that g is like, okay, g came from f after f was multiplied by negative, because you see, g does not have a negative here. So someone could say, well, the transformation is this, g of x, okay, equals to the minus of what? Of f of x. Someone could say that. But is that adequate? Is that the best description we want to have? No, that's not the best description, but it gives us an idea of what happened, okay? So in other words, what you could say is the transformation is such that for xy, for x and y, what we have got, okay, we can use an arrow to indicate the transformation. What we have got is this. X stayed the way it is, but the function was multiplied by negative, okay? The function was multiplied by negative. So now we can say y became negative y. And that's the transformation, which we started from here, you see? We saw that g of x is minus of f of x. And f of x is what? Is the y. And so what that then means is y was multiplied by a negative to make the function change or transform from the original function f of x to this other one, okay? So this would be your solution. You could also say, well, g of x is the reflection of what? Is the reflection of f of x on that line, because it's also the same thing as this one here. You could also say alternatively, the transformation is a reflection in the line. Sorry, I as it, yeah, in the line, you know, in the line x-axis, in the line, or rather in the x-axis. That is in case you want to just have additional description. Okay, in case you don't like the approach of using what? The approach of just using this one. You could say the transformation is a reflection along the what? The x-axis. That would be the solution to what? The solution to your question 2.4. Or if you decide to write just this one is enough. This is adequate enough because this is what we have seen. And this is much more mathematical. You can just clearly see it for yourself. So you could write this, or you could say, alternatively, the transformation is a reflection in the x-axis. So is there any question? Because it's already time to move on to the next lesson. I guess you will also be joining some other classes maybe later. In case you don't have a question, then I think we can stop here for now. Our next mathematics lesson will kick off with the question 3. But for question 2, this has been our what? Our solution. Question 2 was divided into 2.1, 2.2, 2.3, and what? And 2.4. And this is the solution. So I will be uploading this right away. Then you will check it out again in case you want to go over it, like revising and stuff like that. Otherwise, thanks for your time. We will, link up later.